Hi, in this video we're working on fractions. We're in section 2 and we're going to pick up where we left off with equivalent fractions and then using the equivalent fractions to understand the concept of simplest form of a fraction and moving forward a little bit towards common denominators. So we'll see how this all goes. So two fractions are equivalent. So we'll say, for example, that 3/5 is equivalent to 30/50 because there exists a number 10 such that when I multiply 3/5 times 1 in the form of 10/10, I express that fraction as 30, numerator times numerator, and denominator times denominator, 30/50. So that's what makes these two fractions equivalent, that number 10 exists. We can find another equivalent fraction to 3/5. I asked you to find another equivalent fraction. You can randomly choose any number, any whole number, right? So let's say you chose 7. So we'll multiply numerator and denominator by 7/7. And we get 3 times 7 is 21, and 5 times 7 is 35. So we also see that 3/5, we see 3/5 is equivalent to 21, and 21 is equivalent to 30/50. So all of these are equivalent fractions. Okay. So a fraction is said to be in simplest form when the only common factor of the numerator and denominator is 1. All right, so let's look at that. Simplest form. We'll say that 6/7 is in simplest form because the only common factor between the 6 and the 7 is a 1. Okay, so that makes this in simplest form. All right, so but for example, we can look at 12/14, and this is not in simplest form since the common factor of 12 and 14 is 2. So we can write this as 6 times 2 over 7 times 2. And we see that is then equal to 6/7, right? Because that would be bringing the idea of the equivalent fraction. So 12/14 can be written as 6 times 2 divided by 7 times 2. And that makes 6/7. That gives us 6/7 as the simplest form. So to express a fraction in simplest form, I'm gonna give a little way to do that routinely. So we'll say, for example, if we're asked to express 4/16 in simplest form, what we want to do is we want to look to see what the greatest common factor between the 4 and the 16 is. And so 4 goes into 4 and 4 goes into 16. So we're going to write this as 4 divided by 4. And 16 divided by 4, so that's 1/4. So 4/16 is equivalent to 1/4, and that's in its simplest form because I have no more common factors between 1 and 4. So I'm going to give an example here. So for the example, before I move away, I just want to say, if this isn't clear what we're doing, please draw out a brownie pan and break one pan up into 16s and the other pan up into just fourths. and look at how many 4/16 is, how much brownie you get, and look over here how much brownie you get with 1/4 and see that it's the same, okay? So that's the picture that would help with the understanding of what's going on in that, in this relationship over here. Okay, so what we want to do is write 42 over 35 in lowest or simplest terms, simplest form or lowest terms. Okay. So what I want to do is I want to write each of them. So this is one way to do it. You don't always have to go through this process, but this is a process where if you're not sure what to do, you can always jump in. All right, so let's factor this. We can write 42 as 2 times 21 and 3 times 7. So that's 2 times 3 times 7, and 35 as 5 times 7. Okay. So we're going to go ahead and rewrite 42 over 35 in its prime factorization. Okay, so 42 over 35 is equal to 2 times 3 times 7 prime factorization, and the denominator 5 times 7. Okay, and what we see is we can divide out the common factors. We can cancel out the 7, and we get 2 times 3 over 5, or 6/5. Okay, so that's how we can ensure that we have a fraction in its lowest terms. Okay, and so then the other topic we want to connect about before we wrap up this section is just whether fractions are called are like or unlike. So fractions that like fractions have the same denominator, and unlike fractions have different denominators. So let's go ahead and write that out. Two fractions are like if they have the same denominator. It's all about the denominators. That's why when we were doing prime numbers, I kind of wanted you to pay attention to those. And unlike fractions have different denominators. Okay, so I'm going to give you two fractions and we'll figure out which one is like and which one is unlike. Okay, so if we have pairs of fractions, this is 2/5 and 3/5. Those are like because they have the same denominator, and 7/25 and 14 over 24 are unlike because they do not have the same denominators. All right, so we're often given fractions when they're presented in a form with different denominators, and we might have to understand the size of the number that's being represented, even though they don't have the same denominator. So I guess we can start with fractions that have the same denominator, right? So I can look at 2/7 and 4/7. And I know that 2/7 is less than 4/7 because the sevenths, the size of the brownie chunks, are the same, and I either get 2 chunks or 4 chunks, so I know which one is more. But if we have to compare 2/7 to another number, say 3/15, we now have to express these numbers, express these fractions with a common denominator so we can figure out which one is larger and which one is smaller. All right, so I'm going to write each of my denominators in as a product of primes. So 7 is equal to 7 to the 1, and 15 is 3 to the 1 and 5 to the 1. So I want to find the least common multiple. And we know the rule here is to list all the multiples and pull up the exponent that's largest on them. So in this case, my least common multiple is going to be 15 times 7, or 105. So I know that if I multiply my my 7 times 15, I'm going to get 30 over 105, and I similarly can multiply my 15s times 7s, and I can get here 21 over 105. And now I can compare, and I can see that 3/15, which is equal to 21 over 105, is actually less than 2 over 7, which is equal to 30 over 105. All right, so we're actually going to do a lot more with common denominators, I know, and so I know I haven't made this as clear as it needs to be for all common denominator problems, but I just wanted to sort of plant some seeds, and we'll definitely go through that much more systematically in the next video.